welcome back boys and girls. It's your main math man, Mr. Shank, coming to you live from Alameda International High School. In this video, working on some coordinate plane function, graphing some linear equations as well. And we're gonna kind of talk about today what happens when we graph two linear functions on the same coordinate plane. That means, we're gonna have these two equations, and we're gonna go ahead and graph them on this grid, and let's kind of see what we notice. So when we have this, it says, what if you graph two equations in the same coordinate plane? And then we're gonna try to see what happens if they intersect, overlap, or they are parallel to each other. So make sure you're trying to see each of those three options. So what do I want to do to be able to graph these equations? Let's first do this. Well, I know that my Y-intercept is going to be +6, so that means I can plot the point 0, 6. So let's go ahead and plot that first. I have 0, and then 6 is going to be 1 point. And then I can use the slope to be able to build my staircase, so I have another order pair. So it's saying this, my change in y is -2, and my change in x is +3. So I have to go down 2, so down 2, and I go to the right 3. 1, 2, 3. So +3. And this gives me another order pair that will go on this line, which I can now graph. And what I'm going to do is I'm actually going to kind of use two different colors so that way you can see those two different lines. So I'm going to say in blue, for me at least, in blue is going to be this line. And so let's have it like this. Let's have, again, 2 points, draw a line, and we're good. So now that I have my blue line done, I can now graph my next linear equation. And so let's see, I have y equals 1/2 times x minus 1. So I have my y-intercept, that's where it hits the y-axis, and so that's going to be the point 0, -1. So I plot that point first, and then I'm going to say, okay, my change in y is 1, so I go up 1 and to the right 2. So I go up 1 and then right 2. So +1 and then +2, and I have my next order pair to graph my point. So I'm going to do that in red. So I'm going to say, hey, I have two equations. One is in red, one is in blue. And what can I notice about those lines on this coordinate plane? And so if you notice, we can have some things with this. We'd say, hey, some things to take out from here. We know that the blue graph or the blue function is going to be a negative slope as it is going down to the right, and we can say the red equation is going to be a positive slope since it's going up and to the right. But more importantly, we can say, hey, what do you notice about those coordinates, meaning that order pair? Where do they hit, meaning at what point do they intersect? We can say, hey, right at this point right here, they cross over or intersect. So we can say, again, this is where they hit or intersect. You can kind of think of this like a highway intersection, or where two roads cross. So we can say, what's that order pair? Well, I'm going to say, again, an order pair is an x and a y value. And so my x value is 6, my y value is 2. And so for what that means is this. That means that this order pair, 6, 2, is a solution, meaning an answer, to both of these equations. And the way you can check it, again, you can plug in those values and simplify. So that's what I'm going to do. So I'm going to scroll up a little bit, and what I'm going to do is this. Let's do, go down a little bit, and something like that maybe. All right, so let's do my first equation. So I have -2/3, and I have my x value is 6, and then +6, and it's saying, hey, this should equal 2 because that's the y value. So what I did was I plugged in my x and my y values for this order pair into this equation, and then they should be equal to each other. So let's find out. So I have -2 times 6 is -12, divided by 3 is -4. So we're going to say, it does 2 equal -4 plus 6, and we would say this is equal to 2, which equals 2. So we know that one does work out. Again, this we said is a solution to this equation since it falls on that line. And we're also wondering, does it work for the other equation? So the other equation is y equals, again, it's the red one, which actually, let me write that. I have y equals 1/2 x minus 1, and my first equation was y equals -2/3 x plus 6. Let's plug in this ordered pair where they intersect and see if they work. So I have, it should equal 2 because that's my y value, and I say 1/2 times 6 minus 1. That should be the same as 2. So let's simplify. So I have 1 times 6 is 6, divided by 2 is 3. So I'm saying, does this, careful there, does this work out? And you better believe it, it does. And that's why, again, this is kind of that algebraic way of proving why this is a solution. So again, the point where they intersect is called a solution to those equations. So make sure you can kind of notice how those work. Again, feel free to pause, rewind, ask a question at any point in time. That way you know you are good. So now on the back, it has this second case. So it has graph these two equations and write what you notice about these lines. So let's have this. Let's have the equation. Let's do blue and red again. So I have the point 0, 1, and then I can go up 4 and to the right 6. So I go 1, 2, 3, 4, and then right 6. 1, 2, 3, 4, 5, 6. I have my 2 points, which now I can draw my line. So I have my line. Again, use a straight edge. Feel free to ask if you need one. I'm more than willing to share with you. All right, so I have my blue equation in blue, and then let's graph this point, this red equation here. Y equals 2/3 x minus 2. So again, I use that Y-intercept to start us off. So I have -2, the point 0, -2, and then I can go up 2 and to the right 3. So make sure you have that change in y in the numerator, change in x in the denominator. So I have up 2 and then to the right 3, and I have my next ordered pair. Go ahead, make sure you draw a line through those points, like so. We're saying, hey, what do we notice about this? Well, it says identify where the lines intersect. Well, do you notice anything about this? Do they cross at the same point, or do they intersect at all? We would say no, so we would say no intersection. And that means this. That means there's no solution to these equations. We would have to have a point on this graph where both of those lines cross for it to be a solution. So what else do we notice? Hey, I have these two slopes. So I have 4/6, which is equal to 2/3. So same slope means that it's going to be a parallel line. So parallel lines. So that means there's not going to be any solution to these equations for those two linear functions. So let me kind of write that out at the bottom here. So again, make sure you have those parts. Feel free to pause, rewind in case you missed anything. But underneath that, this is what you notice. So what did I notice? I noticed that the slopes are the same, and there is not a point where they intersect. All right, and that kind of helps us understand the different types of cases that we might have for these systems of linear equations. And then lastly, let's kind of graph out what this would look like. So we're going to graph the equation and the table. So we kind of have a table for this one, and we have an equation for here. So what I need to do is I need to take this table and I need to find the slope and y-intercept using this table. And so what I'm going to do is actually this. I'm going to rewrite this table on the side here. That way it's a little bit easier to follow along with. So I have x and y. I have my first order pair. I have 6, 2, 6, 2, and I have 9, 4. So be able to rewrite it, any point in time for yourself. That way it's real simple to be able to solve. What I need to do now, I need to find my change in y. So this is just like that section v.2. Again, find your change in y, change in x, and that is your slope. So I said my change in y is plus 2, and my change in x is plus 3. So that means my slope is going to be 2 over 3. Now that also tells me this. I need to figure out what let's say my y-intercept. That's the point where x equals 0. So let's kind of pick how we want to do this. Well, I can say my change in x is 3, and so what I can do is instead of going down the ladder, I can go up the ladder. So I can say some other ordered pairs that would be on this graph. If this is 6, 2, I can go now up on the x-axis. I can say, hey, this is x and y. Let's go up, and let's say 3, and then 0, and I have 0, negative 2. And so this kind of helps me find my y-intercept. Again, going up that ladder kind of helps us find our y-intercept. So I have to plot that point. And let's do one thing at a time here. So I have my slope, which is m, is going to be 2 over 3. My y-intercept, which is b, is going to be negative 2. Let's always have our function y equals mx plus b, and let's rewrite it. So I have y equals 2 over 3 times x, and then minus 2. So that's going to be, let me actually circle that in blue. That's going to be one equation. So let me graph that point. I have negative 2, and then I have my slope. So I go up 2 and to the right 3. Now I can plot out that point. So let's have it like this. Again, 2 points on the graph, draw a line through them. And then lastly, let's do this. So I have my graph, and also, hey, I didn't even pay attention because I was too overwhelmed. I noticed now that this is the exact same equation that I just wrote down here. Unintentional, I was trying to do one thing at a time. And what happens? Well, since I have that same equation, I go to graph it out, and I would have those 2 points. Go to graph it out in red, and if you notice, it's the exact same equation. That means it's the exact same set of points. So what would we notice? We would say, like this, I would say the lines overlap each other. And that means, again, that same exact functions. That means that the lines overlap each other. And so what does it tell us about the number of solution? Well, that's going to say we have the equation, these equations. Let me take it one step at a time. These equations have infinitely many solutions. And the reason why that works is similar idea. We said up here there's no point where they intersect, so that means there's no solution. However, for this set of equations, they're always the same line, so that means that both of these are going to have the same number of solutions, meaning that whatever value we choose is going to work out for both equations, and so that's how we get infinitely many solutions. So again, make sure you can graph out a linear function, start from the y-intercept, use the change in y and the change in x, meaning the slope, to get to your next point, draw the line, and you're good. Again, feel free to pause or rewind as always, and super slam that subscribe button.